Hey folks. Okay, well, last time through we looked at kind of the plan of attack I would use for our lab exercise 3, and I said that I'd post a complete example of developing a similar program from start to finish. So here I'm going to go through that process. So in my example.cpp here, I've outlined what we're going to try and implement. So it's going to be a program that gets the user to make a choice between two characters, Q or C, Q if they want to quit, and C if they want to do some kind of compute. That's actually supposed to be compute, not the computer. And it's going to continually prompt them until they actually make one of those two choices, and then return the choice that they picked as an uppercase character. So they're allowed to enter lowercase q, we'll return it as uppercase q, and they're allowed to enter a lowercase c, and we'll return it as uppercase. I'm going to switch it up a little bit from the lab, just so we're not too close to the exact solution for the lab. And so for this one, I'm going to use a loop to get the character here, and then we'll use recursion in the other one to get the data value. So we'll have one function, getChoice, to go off and get a character choice from the user. We'll have another function to get an integer value from the user. It's got to be a positive integer, and we're going to store it in a pass by reference parameter. And we're going to use recursion to keep prompting the user until they give us something valid. And finally, we'll have a show results function, which will pass the character and the value, and we'll either get it to display so long and the number if they decided to quit, or get it to compute the number raised to the power of itself if they chose to compute. So this is the idea. The main routine will declare a variable to hold their choice, a variable to hold the value. It'll call getChoice and store the value in the variable. It'll call getValue and pass the value variable. And it'll call show results and pass the two variables to that. So this is the kind of idea for the program. And you can see it's pretty similar, and we just want to work through a complete example here. So I'm going to start from the beginning, and I'm going to follow the same sort of process as we did at the beginning of the actual lab. So I'm going to set up my library and my namespace, and first off we'll get a main routine going here, and we'll just leave the main routine empty for now. Maybe we'll get, well, I guess we can try compiling this and just make sure that we're okay so far. Example.cpp-o example. Okay, compile's okay so far. So we'll start trying to write the prototypes for those three functions. So we've got getChoice that's supposed to go through, supposed to be returning a char. Doesn't need to take anything as a parameter. Now get our Q or C from the user as a char and return it. And again, it's going to be repeating, eventually it's going to be repeating until they give us a valid choice. We'll have our get a positive int from the user, store in the reference parameter. So this will be our get value, and this is supposed to be an int passed by reference. And we're supposed to have a show results function that takes the choice that they made and takes the value that they entered and determine and display the results. So these will be the three functions that we want to work with. And again, I'm just going to copy those and paste them down at the bottom here to make sure that I get the exact same names and spelling and parameter lists and all that kind of thing. And again, these are going to be the full implementations down at the bottom. So we get rid of that semicolon at the end of each line and insert our brackets instead. And the getChoice is going to get the user to provide us with a choice, and we're going to return it. And so we can just try our compiling again. And at this point, it should yell at me because I've got parameters that I'm not using. But other than that, hopefully we're going to compile okay. Let's see. So yeah, warnings about unused parameters. And that ch, we haven't stuck a value in it, but we'll do that shortly. So actually, maybe what we'll do here is just to get rid of that last error message, let's come up with a default value that we'll use here. So we'll start that, that choice off as something invalid to begin with. And we'll see that we get rid of that last error message. So we've got these unused parameters still, but the structure seems to be okay. So maybe what I'll do is set up my main routine to call those beasts, or to declare our variables and call the beasts. So let's say for our main routine, I'll say, well, what do I need? I need a character variable for the choice the user makes. I need an integer variable for the value the user picks. And I want to call getChoice and put the result in my variable. Put the return value in my variable. Right, so I'm going through calling the function. Hopefully it's going to come back with a C or a Q, and that'll get stored in my variable. Then I want to call getValue, and I want to tell it to put whatever the user comes up with into my variable. And then finally, I want to show the results. And I want to tell it, okay, here's the choice that they made, and here's the value that they gave, and do your thing. All right, so I'll get my main routine, and again, compile and see if it seems to work. Maybe we can try actually running it. It's not going to do anything, but what did I call it? Example? Yeah, okay, so it doesn't actually blow up. It doesn't do anything, but it doesn't blow up when I run it. So now we've got the basic structure, the skeleton, if you like, the bare bones of our program implemented. Let's just take these things one at a time. And first, we won't worry about repeating. We won't worry about error checking. We'll just get it to do the bare minimum and prompt the user and read their response in. So let's prompt the user to enter Q to quit or C to compute. And we'll read in their choice. And maybe let's leave it at that for the moment, and let's see if that compiles and works. So again, we're still getting warnings about unused parameters for stuff that we haven't worked on yet, but we can try running it and see if it actually asks me for my choice. Enter Q to quit or C to compute. So we'll enter a choice, and again, it doesn't do anything with it yet, but so far so good. So maybe I'll throw in one more thing here while I'm at it and say, well, I wanted to convert that thing to uppercase eventually anyways, so let's throw that in now. Let's replace whatever they typed in with the uppercase equivalent. Right, so convert to uppercase, so that later on when I do add the error checking, I don't have to worry about whether they entered upper or lowercase. And we'll just see if that still compiles, and still looks good. Still seems to run okay. All right, let's keep going. So now we've got, hopefully it's actually entering the data correctly. Let's, and if you wanted to at this point, if you wanted to get a little confirmation, we could duck in here for a moment and just see if the correct value is getting back to the main routine. You chose, and whatever's in choice. So we can just do a quick check here and see if the correct value is actually getting there. We're going to take that out before we actually kind of submit this thing, but just for the moment, just to double check. So if I enter Q, hey, it says I chose Q. If I enter a lowercase q, hey, it converted it to uppercase. If I enter a 9, so again, we can go through and we can at least trust that it seems to be working that far. Okay, I'm going to remove that now before I forget about it. So the correct choice seems to be getting stored and making it back to the main routine. So now let's try the same sort of idea for our value. So for this one, we'll say enter a positive integer, and we'll read it into val. All right, so at this point, that's all that we're going to do. We won't worry about the error checking or getting it to repeat yet. And so we'll just go through this process one more time, and you can see that we're gradually getting rid of our warnings there as we're actually using our parameters. And so now I say, okay, well, I want to quit, and I'll give it a positive integer. Okay, so far so good. And again, if we wanted to double check that this seemed to be working, we could stick in a well, actually, no, we're going to do show results next anyways, so let's see when we get there if we actually see some results, because we're practically there. So we can read a value, or two values in, and in our show results, for this one, we want to see if they chose Q or C or something else. Now, in theory, it should never be a something else, but just in case we made a mistake elsewhere in our program. So if the choice is equal to a Q, then we want to handle the quit case. Else, if the choice is equal to C, we want to handle the compute case. Else, this shouldn't happen. Means something is buggy, right? Since we're since in theory only an uppercase Q or uppercase C should eventually be making it back, we shouldn't reach this case, but we'll throw in a test just in case. So that means a bug someplace. So once we've got our error checking in place, actually I should maybe put that here. This shouldn't happen once our error checking and repetition is working. So until we get our error checking working, of course, something might sneak through. But this will be the idea. So maybe for now, just to kind of start this out, what did we want to do? What did we say our specs were for this? For the quit case, we want to say so long and then the number. So if they chose to quit, we'll say so long, show them the value that they picked, and that'll be it. Otherwise, what were we supposed to do here? If they chose to compute, we want to compute the value to the power of the value. Ooh, that means we better use our C math library. So let's throw that in while we think about it. And so in this case, our compute value is, and so we'll go off and work out value to the power of value and print that out. And then in my else case here is invalid choice crept through. So I've got my the basics of my show results, and this is probably all show results is really going to need, since all of the error checking and whatnot is going into the two routines for getting the choice and the value. So this might actually be it for show results. So let's try compiling again, and our warnings are gone since we're actually using all our parameters now. So let's try running this thing, and if we try Q to quit, it's going to ask me to enter a positive integer, And yeah, we got our, when we chose to quit, it said so long and gave me a 10. Let's try the same thing with a Q. And I don't know, 20. So long and 20. Let's try it with an uppercase C. And hopefully 5 to the 5 is actually that. Let's try with lowercase c, and let's try 2 to the 2. And that looks okay. So we seem to be getting okay there. Let's throw one more in just with an X or something like that. And hey, it's actually picking up on the fact that an invalid choice crept through. So we've got our basic functionality working at this point, right? We've got something working. None of the error checking, none of the repetition works yet, but we've made some decent progress. So let's get some of the repetition going. So for get choice, we said we would use a loop to go through and keep going until they gave us a Q or a C. So let's do that. So for get choice, now we want to wrap a loop around this and keep going until they give us something valid. So I'm going to have, again, a Boolean variable that says, the data is bad. So this is true for bad data, false for good data. And I'm going to throw a do while loop around this to keep going while the data is bad. Now, remembering our indentation rules, everything inside the do while needs to get indented, so we'll do that. And so this loop is just going to go through over and over and over again while the data is bad. So that means that I need to do some error checking in here and decide if the data is good or bad. So we've converted it to uppercase right after that to upper. So all I have to check is if it's a Q, it's okay. If it's a C, it's okay. If it's anything else, it's bad. So if the character they entered is an uppercase Q, then I can say data bad is false, right? It's a valid quit. Else, if the character they entered is a C, then data bad is false. It's a valid compute command. Otherwise, they entered something else. So if it's anything else, then I'll say data bad is true, not a valid choice. And so I'll give them an error message. Now let's say invalid choice, and we'll remind them what they actually entered. CH. Try again. And I think that should be pretty much it for my error checking. Right, I'm going through, I left my prompt and my conversion to uppercase pretty much the same. And oops, here we've got a couple of bugs. Again, it's 2 equal signs for comparisons. So if the character is equal to the uppercase Q, or if the character is equal to the uppercase C, it's okay data, we don't need to repeat. If it's anything else, we do need to repeat, give an error message, and we'll see how this goes, right? It'll eventually get out of this loop when they, somewhere down the road, give us good data, and once we get out, we'll return the data that we got. So let's give this a try and see if we actually got that up and running. So let's see if it still works for, let's say, valid data. So that looks okay. That looks okay. So for computing, I have no idea if that's if that's what 40 to the power of 40 actually is, but since our other computations appear to be about right. Let's do an uppercase C and try 3 to the 3. So we know what that is. Yeah, okay, that's all right. So it looks to be working okay if we give it valid data. Now let's see if the error checking is starting to work. So we'll throw in an X. It tells me that's an invalid choice. Of course, it's converting to uppercase before it gives me my error message, which might not be entirely ideal, but close enough for the moment. So let's see if we try more invalid choices. So let's try 9. Invalid choice 9. You know, let's try something weird. We'll try a bracket. Invalid choice bracket. So the error, it's giving me errors again and again and again. Now let's see if after the errors, if I enter something valid, if we do get there. So let's try a Q. Hey, yeah, okay, so it seems to have accepted that. And again, we'll try our positive integer. Yeah, so the error checking appears to be working on our get a character. So we're getting pretty darn close, right? We've got our show results seems to be working. We've got our get choice seems to be working. Our main routine seems to be working. The get value is working if they give valid data. We just have to throw in the recursion here to get it to work, to get it to repeat if they enter invalid data. So for our error checking, now we want to start adding our recursion. So we'll go through and say, all right, well, what can go wrong? They could enter something that isn't an integer, in which case we have to do our buffer clearing, or they could enter something that's 0 or negative, in which case we just need to get them to try again. So if cin failed, right, we'll need to flush the buffer. Else, if the value is too small, then it's just an error, and we'll deal with that in a second. Otherwise, it's okay. So let's see. If we, in the flush the buffer case, we want to do our cin.ignore, and we want to give it some kind of a value, but again, we want to adhere to our standards, so we'll create a constant for our line length here. And we'll keep going until an end of line. So I'm just going to jump to the top and have a constant for my assumed maximum line length. And whatever you want to pick as a number there. Oops, I guess I should make sure that the names actually match here. So we'll flush the buffer, we'll do our cin.clear, and we'll let them know, you know, that was not an integer. Please try again. And we'll do our recursive call. Now this is going to be a little bit different than our other recursive calls, because in this one, the value is going into the pass by reference parameter rather than getting returned, right? Ordinarily, we'd be putting this return value someplace and eventually returning that. But because this one is putting the value directly into the parameter, we don't actually need to do our return on this one. So, or to store a returned result. There is no returned result. So, we've got our attempt at error checking if it was not an integer. The other possibility is it was too small, so we'll let them know that was not a positive value. Now please try again. And again, we'll do our recursive call to get the response. All right, so in theory, this should about do it, right? If they entered something valid, then it wound up in our pass by reference parameter, so it's already taken care of. If it was garbage, then we're clearing it and making a recursive call to get the new value. And if it was too small, then we're making a recursive call. So let's give this a try and see how we go. So let's do Q to quit, and it's going to ask us for a positive integer. So let's try 0. That wasn't a positive integer. Let's try a negative number. And then let's try a positive number and see if we get anything going here. All right, so it actually does seem to be working for us. Let's try our C for compute, and let's try, foo. Oops, whoa. Okay, so we're not catching our cin.fails. What did I miss? If cin failed, we're doing our did I get a valid line length up there? That looks okay. We're getting them to try again. What am I missing? This is one of those cases where I'm not spotting where my error is, and these are the kinds of things that will eventually drive you nuts. What was the error message I was getting? That was not a positive integer. Please try again. Fail. So it is certainly doing our recursive call. What have I missed? I'm not spotting it. So if we do our Q and we do an X, okay, so it's catching a single invalid character. Oh. Did I just not recompile last time around? Did I forget to recompile? Okay. I think maybe I just forgot to recompile. Okay. Well, again, those are the ones that make you feel a little foolish, but we do appear to be working. Go. All right. So I guess we should, let's try our foo again. Yeah. So again, the, going through here, we're trying, if I type in something like a word for that first single character one, of course it's going through character by character and saying, okay, well, it reads the first one and says that's not valid, reads the second one, says that's not valid, reads the third one, says that's not valid. If we try our foo for oops, I guess we should get past that. So let's give it a valid command and try our foo. Yeah, so it's going through and apparently error checking correctly. Let's throw in some zeros and some negatives and some garbage again. And eventually give it a positive integer and see how we go. All right, so we do seem to be doing okay now. But again, that's the basic cycle. You take this through incrementally, develop one piece at a time, check it, see if it seems to be working, right? Compile it, do some testing, and eventually you wind up with, hopefully, a working product. All right, so that should be the end of that one. Good luck with the lab.